Hi, welcome to scBIRD tutorial. We will start by uploading a gene expression matrix, which should be saved in RDS format. This data comes from Human Cell Atlas Immune Cell Profiling project on bone marrow. We read in the data, it has 33,000 genes and 48,000 cells. A snapshot of the data is provided. The rows are genes and the columns are cells. We hit Next and come to the step of quality control. scBIRD provides three metric options to identify low-quality cells: the total count across all genes of a cell, the number of expressed genes, and the fraction of counts mapped to mitochondrial genes. Users could choose the threshold of metrics to filter cells. The default threshold are 3 median absolute deviation away from the median value of the matrix after being log transformed. We set up the threshold and click Filter Cells. The distributions of the matrix are visualized using violin plots. On the plots, each point represents a cell corresponding to its metric value on the y-axis. The points are colored. They will be colored orange if they're of low quality, and they will be colored blue if they're of high quality, based on the threshold by the user. And low quality cells will be removed. A summary table is provided showing how many cells are filtered out because of each matrix and the total number of cells left out. We continue to the normalization step. Press Random Sample 50 cells to generate box plots that show the gene expression distributions. The x-axis of the box plots are 50 randomly generated cells, and the y-axis are the log transformed expression value of a set of selected genes. Click Log Normalize to perform library size normalization. Normalized gene expression distributions of the same 50 cells are displayed. We could see that the systematic difference in gene expression levels between cells are removed. We hit Next and come to the gene selection step. We want to identify highly variable genes, and we control the number of genes by choosing false discovery rate. Here we use a FDR of 0.05. The black line represents the estimated technical variance trends, and the blue dots are selected as highly variable genes because their total variances are higher about the technical variances, implying some true biological variances. The summary table says we have selected 500 genes, and these genes will be used for dimension reduction in the next step. The data will be compressed into 2 dimensions, using either t-SNE or UMAP by the user's choice. 2 clustering methods are provided: graph-based clustering and k-means. Here we're using k-means. Based on our prior knowledge, there are around 35 cell populations in this data, so we set the number of clusters accordingly. And here's our t-SNE plot. Each point represents a cell and is colored according to its cluster. After all of these pre-processing, finally we're going to perform BIRD prediction. Users need to have a training model saved locally. 4 models pre-built by Wei-Cheng Zhou are available on GitHub. Here we upload the model bin file. 2 predicting options are available. If the user is interested in the regulome activity of a certain genomic region, users could specify the chromosome start and end and press the BIRD Logi button. scBIRD will output the aggregate predicted signal for this genomic region. Another option is to give the ensemble ID of a gene and click BIRD gene. The aggregate signal for the loci adjacent to this gene will be predicted. And here we're showing an example of a gene called MYC, and we're interested in its nearby transcriptional activities. The same t-SNE plots from our previous steps are displayed. On the left, each cell is colored according to expression level of the gene MYC. On the right, each cell is colored by the aggregate BIRD prediction at proximal promoter regions of MYC. The group of cells on the upper right corner that have relatively higher expression level of MYC also have higher predicted DNAS levels at adjacent loci, implying strong regulatory activities around. And this concludes the walkthrough tutorial of scBIRD. I hope you enjoy it.